So in previous videos, we've been focusing very much on the mechanics of using the power rule in order to find values, I suppose, or to find the gradient function or the derivative, all the same thing, derivative, gradient function. So in this video, we'll just have a look more precisely at, what using the power rule gives us, I guess. And in this instance, you can see I've got a graph here, f of x equal x squared plus 3. And I've graphed it here and just plotted out 3 points at 3 different kinds of locations, I suppose. On this side of the graph, I've got -3, 12. And you can see that works. If I go -3 squared, it's 9 plus 3 is 12. So that's an actual point. I've got this point here, 1, 4. 1 squared is 1, plus 3 is 4. So that's 1, 4. It's that point there. And then we've got the turning point as well, which I don't have labelled as a point, but just I've labelled the y-axis at 3. Okay, so again, you might want to pause the video after I've asked each question, but what's happening to the gradient, or what's the gradient like at that point? And what's the gradient like at that point? And what's the gradient like at that point? So we can see here that if we're moving left to right, the gradient is negative because it's going downwards. And it's also getting flatter, so it's decreasing. So it's negative and decreasing along here. And it gets to the turning point, whether it's neither positive nor negative, so it's 0. And then after that point, it's starting to speed up again, so it's increasing. And it's also positive. We can use the derivative to back up these facts. So let's start off by working out the derivative. F of x equals x squared plus 3. So f dash of x is simply equal to 2x. Yeah, the 3 disappears because it's a constant value, and the x squared, the 2 goes down. So it's really simple. Now that we've got the derivative, we can substitute values in to see what's happening at those points. So in this instance, the y-coordinate doesn't matter so much. We're looking at the x-coordinate because that is the input to the gradient function. So first of all, if we have x equal to -3, then we would have f dash of -3. So that's the derivative function evaluated at -3. And it's equal to 2 multiplied by -3, which is -6. And that confirms what we think would be happening here. Okay, it is a negative gradient all the way down to here, but it's also negative decreasing. So let's pick another point, like here. And let's just say this is -2. So what's the y-coordinate? You figure it out, and then I'll come back to the video. Okay, if you said the y-coordinate is 7, you'd be right, because -2 squared is 4, and 4 plus 3 is 7. So if I go to f dash of -2, this is the gradient at the point x equals -2. I'll put that in too. Then we have 2 multiplied by -2, which is -4. So we can see the gradient, which was -6, is now going to -4. Okay. So it's becoming a smaller number, and therefore it is getting flatter. It's decreasing. Okay. Let's have a look at x equals 3. I'll start the same way. At x equals 0, beg your pardon. It's y equals 3. So when y equals 3, x equals 0. At x equals 0, f dash of 0 is equal to 2 multiplied by 0, which is 0. And that confirms what we would expect as well. It is neither positive nor negative. It is neither increasing nor decreasing at that point, the turning point. And at x equals 1, what did we say again? We said that it's a increasing graph, and the gradient is increasing and it is positive. So if we substitute in 1, we get 2 multiplied by 1, which is equal to 2, which is a positive number. So the gradient is in fact positive. So that's the link between the gradient function, and it allows us to work out what's happening at specific points in the original function. Okay, let's have a look at a couple of examples. Example 1. For y equals 3x squared minus 2x cubed, if x equals negative 2, so we're given the x coordinate because that's the critical thing here. Find the y coordinate. Okay, they want me to work it out as well, and the gradient of the tangent line at that point. Now we're going to have a look at tangents and normals to the function a little bit later on in the course, but the important thing is that the gradient at that point will be the same as the gradient at the tangent line. We'll tease that out in a separate video, but that's what you're basically looking for, the gradient at that point. So let's start by doing what it asks, and that is number 1, the y coordinate. So the y coordinate is at x equals negative 2. So let's just substitute in y equals 3, negative 2 squared, minus 2, negative 2 cubed. We can probably do most of this in our head. Negative 2 squared is 4, so we've got 4 3s are 12, and we've got negative 2 cubed is negative 8. So remember, when we raise a negative number to an odd power, the result is negative. When we raise a negative power to a negative number to an even power, the result is positive. So we're going to have 8 times 2, which is 16. So it'll be plus 16 because it's a negative times a negative. And that's equal to 28. And so the coordinates are negative 2, 28. Now the gradient, this is point 2, the gradient at negative 2, 28 is going to be found by first finding the derivative, y by dx is equal to 3x squared becomes 3 2s are 6, x to the power of 1, which we don't write in, and minus 2x cubed becomes minus 2 times 3, which is 6, x to the power of 2. And we need to know the gradient at x equals negative 2, so we substitute that in. And we solve. 6 times negative 2 is negative 12. Negative 2 squared is positive 4, so we've got minus 6 times 4 is just minus 24. And that gives us minus 36. So the gradient at that point is negative 36. So it's a negative gradient. And at negative 36, it's pretty steep as well. Let's have a look at example 2 now. I do encourage you, by the way, not just to solve problems, but to also think about what the answer means in terms of the function. If you keep on doing that, you'll end up in a much better place with being able to answer questions and figure out what's going on in graphs and stuff, because your mind will be used to going, oh, minus 36, negative gradient, quite steep, that kind of thing. Okay, example 2 is, let's just say we're given a gradient. So find the points on the curve with gradient negative 12, given that the function is y equals x cubed minus 6x squared plus 4. Okay, so the first thing we're going to do is find the derivative, because the derivative gives us the gradient. Function dy by dx is equal to x cubed, use the power rule, 3x squared minus 12x to the power of 1, which we don't write in, and the 4 disappears. Now, that's the derivative function, the gradient function or the derivative, but we're told that we're looking for the value of x and y if it exists, well, it does exist, with gradient negative 12. So we're going to have to say that that gradient is equal to negative 12. And now it's a matter of solving. So I'm going to bring over the negative 12, so add 12 to both sides, and that makes it 0 on the right. And now we can use the null factor law to solve this. Step 1, is there a common factor? And there's a common factor of 3. So we're going to divide both sides by 3 all the way through, and we end up with x squared minus 4x plus 4 is equal to 0. Number 2, does it fit a pattern like perfect square or dots? Well, it can't be a difference of 2 squares if there are 3 terms. Is it a perfect square? This is 2 squared, so that's a good start. This is x squared. So between them, that would be 2x. Do I have twice 2x in the middle? Yeah, I do. It's minus 4x. So this is x minus 2 all squared is equal to 0. It's minus 2 because this is a minus here, just to remind you. And now we can use the null factor law to show, therefore, x equals 2. This is the x coordinate when the gradient is minus 12. We are asked to find the point, not the x coordinate. So we need to substitute in 2 for x to finish off the problem. So y is equal to 2 cubed minus 6 times 2 squared plus 4, which we can then take it to its conclusion. 2 squared is 4 times 6 is 24. And that leaves us with minus 12, I think. Okay, so that leaves me with the point 2 minus 12. Or if you like, you can conclude by saying i.e. the point at which gradient is 12, negative 12, is 2 minus 12. And you're done.